Welcome to Easy Driver, the most reliable source of automotive information on YouTube. Please like, share, comment and subscribe. Dive deeper into advanced tuning techniques, real-world applications, and what this means for EV performance and efficiency. Software Optimization and Battery Management Systems, BMS. Battery hardware is only part of the story. Advanced software plays a huge role in getting the most out of an EV battery. Think of it as the brain of the battery system. Sophisticated battery management systems, BMS, are essential for tuning battery performance on a digital level. These advanced BMS units do several important things. Optimize charging and discharging cycles. They precisely control how quickly the battery charges and how power is delivered, preventing stress on the cells. This helps extend the battery's life and maximize the usable range. Predict battery degradation. By constantly monitoring performance, the BMS can estimate how the battery is aging. This allows for better maintenance planning and more accurate range predictions for the driver. Extend usable range. The BMS ensures optimal thermal conditions by managing heating and cooling systems. It also balances the performance of individual cells within the pack. This prevents one weak cell from dragging down the entire system, ensuring that you get the maximum possible range from every charge. These software advancements are critical for squeezing every possible mile out of the battery without compromising its health or safety. The road to solid state, bridging the gap in 2026. While many in the EV world dream of full solid-state batteries, widespread commercial deployment by 2026 is still a big challenge. These batteries promise greater safety, higher energy density, and faster charging, but perfecting their manufacturing at scale takes time. Japanese automakers understand this. They are not waiting for a miracle breakthrough. Instead, they are taking practical steps. The current tuning efforts we discussed earlier are critical. They serve as valuable stepping stones, helping engineers refine battery technology and prepare for the eventual shift to solid state. Think of it as a gradual evolution, not a sudden revolution. By 2026, we might see the beginnings of solid-state components. These incremental advancements might appear as hybrid or semi-solid-state solutions. This allows for real-world testing and data collection. Every small advance helps bridge the gap between today's lithium-ion batteries and tomorrow's full solid-state future. Partial solid-state integration and pilot programs. By 2026, it is possible that some Japanese automakers will start introducing limited, high-performance battery packs that include partial solid-state components. Imagine a scenario where a small portion of the battery uses a solid electrolyte, while the rest remains liquid. This hybrid approach offers several benefits. It allows manufacturers to gain experience with solid-state materials in a controlled environment. These packs might first appear in specialized models or for specific applications, rather than in mass-market vehicles. Consider these initial integration strategies. Limited run, high-performance models. Automakers could use these specialized packs in electric sports cars or luxury EVs. These vehicles often have higher price points, which can absorb the added costs of new technology. Pilot programs in specific regions. Testing new battery tech in smaller markets or with fleet vehicles helps gather valuable data. This approach reduces risks before a wider rollout. These pilot programs are crucial for the learning curve. Engineers can collect real-world data on how these batteries perform under various conditions. They can assess everything from charging cycles to temperature fluctuations. This feedback is vital for refining the technology. It helps identify any unforeseen challenges and accelerate the development of full solid-state solutions. It is a smart way to dip a toe into the solid-state water without diving in completely. The role of manufacturing advancements. Battery manufacturing processes are also getting a lot of attention. You can think of it as tuning the factory floor itself. Improvements in precision, quality control, and automation are indirectly boosting overall energy density and reliability in 2026 models. Better manufacturing means better batteries, even with existing chemistries. Here's how manufacturing advancements make a difference. Enhanced precision in material layering. Modern factories can layer battery materials with incredible accuracy. This consistency helps maximize performance by ensuring optimal ion flow. Fewer imperfections lead to more stable and efficient cells. Higher quality control standards. Stricter checks throughout the production line catch flaws early. This reduces defects and ensures that every battery cell meets high standards. A consistent batch of cells performs better and lasts longer. Increased automation in assembly. Robots and automated systems handle delicate components with greater care and speed than human hands. This reduces errors and creates more uniform battery packs. It also helps scale up production to meet growing demand for EVs. These improvements mean that even current battery chemistries can achieve higher performance and better safety. By refining how batteries are made, Japanese automakers are building a stronger foundation. This foundation not only enhances today's EV range but also paves the way for the sophisticated manufacturing needed for future solid-state batteries. It shows that innovation happens on many levels, from the chemistry itself to the factory processes that bring it to life. Japanese automakers are making smart moves to boost EV range by 2026. They are not waiting for a single, new battery to appear. Instead, they are carefully improving existing lithium-ion technology. This means refining the chemistry inside battery cells, designing smarter battery packs, and using advanced software to control everything. These steps, while incremental, will lead to electric vehicles that can travel much farther on a charge. We as consumers will soon see more competitive long-range EVs. This focused innovation points to a very exciting future for electric cars, making them more practical and accessible for everyone. Please comment, like, share, and subscribe for more automotive information like this. Thank you for watching.